So these are the types of antennas, that is the omnidirectional antenna as well as the directional antenna. Totally depend upon the direction, particular application. We can say they totally depend upon the directional antennas. Okay, depend upon the directions. So in this here, the frequency will be different in the many places. The frequency will be lower. Okay, and the direction of this antenna would be large. So simply to cut the cost, most of the time we required have you seen the wireless cordless mobile on that small antenna is there, the circular shape and the strip is there. We need to open it and we need to press. So that is one of the example of your the omnidirectional antenna, just because we used to get it for the low cost, you can say reasonable cost or the low cost. Okay, and the directional or the beam antenna, directional antenna is also known as the beam antennas, which are what we can say used most widely used for the radiated or receiving at a particular direction or the directional pattern. Okay, so that is useful. Similarly, according to the length of the transmission line available, the antennas are generally falls into the one of the two one more categories, and that is nothing but your the resonant antenna as well as the non-resonant antennas. Okay, resonant antenna and non-resonant antenna. So it's a totally depend upon the length of the transmission line. So resonant antenna is the transmission line, that length of which is exactly equal to the multiple of the half wavelength, and it is open at the both the end. It means that resonating point, already we have studied about what is mean by the resonant, okay, in the network analysis subject. Okay, so one of the example is nothing but your the Z is equals to R, that is the input resistance will be equal to the impedances. Okay, that time, and even at a resonating point only. Okay, when the XL is equals to XC. Okay, at the time also you can say the circuit is resonant, and at the time we can get the many benefits depending upon the resonant conditions. So that type of antenna is used if the length matters. Similarly, non-resonant, the length of this antenna is not equal to exact multiple of the half wavelength. Wavelength is that we are interested. We are talking about the length in the form of the electromagnetic wave is nothing but the wavelength, that is denoted by the lambda. In these antenna, the standing wave ratios are not present. Standing wave ratio, VSWR, what is standing wave ratio? Already we have studied. Okay, it's not present at this antenna. So are terminating in the correct impedance, which is avoided reflection. So the wave travel only in this direction is nothing but non-resonant antenna is unidirectional antenna, means the flow will be from the either the source to destination or the destination to the source itself, not more than that. Unidirection, one direction only. So this is the one of the best radiation pattern in that our antenna is placed. We are interested to find out uh, the side loops. We are interested to find out the main lobe. We are interested to find out the opposite side loops, etc. Okay, so here if you observe, see here the looping, how that at the 180 degrees, see here the at 0 degrees, here the minor side loops are there. Okay, minor side loops are also there. So how they are placed in each and orbits. Okay, if you are taking this circular path, if you are finding this the axis, so 0 to 270, 180, likewise this we can find each and every loop. Okay, what will be the effect of this small loop, what will be the effect of this opposite large and the main loop, so that we will study in depth later on. So the radiation pattern is useful for this antenna to plot the field strength of the radio waves emitted by the antenna at a different angles. Similarly, it is presented by the three-dimensional graphs, polar plots, you can say the horizontal, verticals, okay, cross even. So we are interested here to find out the field strength. Okay, field strength denoted by the in terms of the electric field is E, and that is measured in terms of the volt per meter. So in this way, the pattern of the idea as tropic antennas, which is here. Okay, so many non-directional antennas such as the dipoles emits equal power in the horizontal direction with the power dropping off at a higher and the lower angle. So at the side loops, just you have seen at the side loop, there is angle. You can find the angle in the vertical, in the horizontal, in the cross. Okay, if you go through the previous slide now, so you will be able to find here will be small angle. You can find at the slanting way, you can find the angle, you can find the side lobes, main lobes, and the opposite lobes also. So in this way, you can find here the with the help of the directional, omnidirectional, and non other things we can find. The radiation of a many antennas shows the patterns. The maxima is also known as the loops. So wherever the word loop is used, it means that the maxima portion, okay, with along with the angles, okay, separated by the nulls angles where the radiation falls to zero. Wherever you are coming, the 0 degree means nulls. This is because the radio waves is emitted by the different parts of the antenna, typically that is in the maximum radio waves is there arriving at a particular point that is in phase. So whenever in phase is there, the register value becomes as the zero that we are aware in phase. That's why the XL is equals to XC at a resonating point, but the register will be the zero just because of the in phase, the main loop. So loop are a side loop, main loop. The loops are nothing but the maxima things or the main things. Okay, main loops. So antenna, various parameter we need to calculate while we are designing, that is a bandwidth, frequency, the antenna gain, the antenna beam width also, the aperture also. So these are the gain, the basic what we can say, the one of the parameters, that is the gain. Gain is the parameter which measures the degree of the directivity of the antennas, in which direction the radiated patterns, the high gain antenna will be perfectly radiated in the particular direction. So in this way, antenna gain is too important, that antenna gain is to also give the information about the power gain. So in terms of your the voltage and the currents, we are interested to find out what will be the gain of that particular antenna. Okay, so the gain of antenna will be the passive phenomena, and we are aware that how we can find out the certainty while you are going to transmit, while you are going to receive, whether you are receiving high gain or the low gain. If you are getting the high gain, the antennas have the advantages of a longer ranges. If gain is larger or the high gain is there, means the longer range will be, the length will be the larger one, and the better signal you will get, the qualitative signal you will get. Okay, so if you have a very low gain, the antennas has will be the shorter ranges, that wavelength will be shorter, lambda. Okay, so in this way you can find the things. Similarly, depending upon the antenna efficiency, you can find easily the antenna efficiency of the transmitting antenna is the ratio of your the power actually radiated to the power observed by the antenna termination. One of the theorem we have studied in the network analysis, that is the maximum power transfer theorem. How much amount of the power is transmitting from the source to the destination, from the source to the terminating point, that is nothing but the RS is equals to RL. Might be you have remembered, yeah. So that time we are interested to find out the power P, okay, maximum power transferred from the source to the destination with the help of that theorem. So similarly here, we are interested how much amount the power is transmitting from the terminating or the from the source to, and how much radiating, and here how much observing. So these things we can find, and depending upon that only the antenna efficiency shows itself, how the things, how the power will be radiated and how the power will be observed by the particular antenna. Okay, so in this way, what we can say, the power supply to the antenna terminals, which is not radiated and converted into the heat. Okay, this is usually through and even the losses of resistor we can find, the conductor we can find the dielectric or the magnetic core losses. After getting all these things, means these are the basic components we need to find out while you are going to measure the antenna efficiency. The polarization is here. Polarization of an antenna is the orientation of the electric field, that is the E plane. You can say the radio wave with respect to the earth surfaces, and determined by the this physical structure. A polarization of mounted vertically, horizontally, you can measure the refraction will be the case. The low frequency, LF is nothing but low frequency, VLF very large frequency. These the frequency ranges we can find. Okay, we can find the antenna if you are having the vertically polarized section. So beam width is the next one. The beam width, one of the parameter we are interested to find out while designing. Beam width of antenna is defined as angular separation between the two half power points of the power density radiation pattern, the angular separation between the two 3D. How we got this 3dB, that we will see very soon with the help of the curve in the next session. We are interested to find out the field strength of the radiation pattern in this way in terms of the degree that will be reflected. So basic block diagram of the radio link, because already we are talking about the electromagnetic wave or the radio waves. So see here, the transmitting, then the transmitting antenna will be placed. In between that, the wave will be propagate, the path will be there, and the receiving signals will be received by the antenna, and the main receiver will be there. So this is the radio link. Okay, so in this way, today we have studied about the basic things related to the antenna introduction, the types of the antenna, basic types of the antennas, then the parameters related to the antenna designing, the gain, the efficiency, the beamwidth, etc. Okay, and we have also learned about what is the objective behind the learning of the subject, what will be the outcome after the 3 to 4 months after ending, after starting this subject. Okay, so in this way, I am going to end this session. In the next lecture, we will continue about the introductory part once again about the antenna. Thank you so much.